Hello all, this is Narayana Reddy from Narayana Group. I am going to discuss Shift 1 JEE Mains 22nd morning paper. So this is physics paper. First question, a small point of mass m is placed at distance 2r from center O of big uniform solid sphere of mass m and radius r. Gravitational force on m due to m is F1. A spherical part of radius r by 3 is removed from big sphere as shown in the figure, and gravitational force on m due to remaining part of m is found to be F2. The value of F1 is F2 is, first of all, field due to original sphere at a distance 2r from center of sphere, as it is external point, field produced by this can be written as gm by 2r whole square. So force experienced is field into mass of the point mass. Now when some part is removed from the sphere, field at the same point due to remaining sphere is vector sum of field produced by original sphere and field produced by removed part. It comes out to be, if it is E2, field of original sphere is gm by 2r square as usual minus field due to removed part, g into mass of removed part here will be m by 27 as it is proportional to r cube, into distance of removed center of removed part from the point mass will be r plus r by 3 as its radius is r by 3. This is 4r by 3 whole square. So this will be gm by 4r square minus gm by 27 into 16 r square by 9. Let us take gm by 4r square common from this expression. So it will be 1 minus 1 by 12 it comes out to be. So this is equal to 11 by 12 times of gm by 4r square. Now force experienced in the second case equal to E2 into m. Ratio of F1 and F2 will be E1 into m by E2 into m. So it is clear from this, it comes out to be 12 by 11. Gm by 4r square, gm by 4r square gets cancelled. So first option will be the correct answer. Let us go to the second question. So here sliding contact of a potentiometer is in the middle of potentiometer wire having resistance 1 ohm as shown in the figure. Here diagram is bit missing. Actually here it is given a source of EMF 0.9 volt and this is an external resistor of resistance 2 ohm which is connected to, this diagram is missing here, I think it is like this. This is the potentiometer wire. The resistance of potentiometer wire given is 1 ohm, external resistor is of 2 ohm, voltage of cell given is 0.9 volt. Now sliding contact is kept at the midpoint of the potentiometer wire, is asking to find current in the circuit. So here it is clear, this 1 ohm can be divided into two parts, half ohm here, half ohm here. This half ohm is in parallel with 2 ohm resistor, so it comes out to be, the circuit can be rearranged like this. This half ohm resistor is in series with parallel combination of half and 2. So let us find the effective resistance of this parallel combination. Half into 2 by half plus 2 multiplying with 2 on both the sides, it will be 2 by 1 plus 4, it will be 2 by 5. 2 by 5 is in series with 1 by 2. So effective resistance of the combination is 0.4 plus 0.5, this is 0.9. EMF of cell is also 0.9 volt. So current flowing through battery will be 0.9 by 0.9, this is 1 ampere. Answer is given with option 3. Let us go to the next question. An electron is made to enter symmetrically between two parallel and equally but oppositely charged metal plates, each of 10 centimeter length. Electron emerges out of electric field region with a horizontal component of velocity 10 power 6 meter per second. If magnitude of electric field between the plates is 9.1 volt per centimeter, then the vertical component of velocity of electron is given that mass of electron is 9.1 into 10 power minus 31 kg and charge of electron is also given. Let us consider two parallel plates to be like this. Length of each plate given as 10 centimeter. Electron is projected with velocity v naught, let us say. Suppose if electric field between the plates is like this, as it is negative charged particle, it experiences force in the direction opposite to electric field. So, it comes out from the plates like this. During its motion, x component of velocity remains constant, so it remains as v naught, and it acquires y component of velocity vy. Vy can be written as y component of acceleration into time taken to cross the plates, where time taken to cross the plates is x component of displacement L by x component of velocity v naught. X component of displacement is nothing but length of plate, that is 0.1 meter, by x component of velocity 10 power 6 meter per second. So, it is 10 power minus 7 seconds. During this time interval, y component of velocity acquired should be calculated. So, let us find y component of acceleration. This is magnitude wise E by m. Charge of electron 1.6 into 10 power minus 19, and electric field strength between the plates given is 9.1 volt per centimeter. If it is converted into SI units, it will be 9.1 into 10 power 2. Now, mass of electron 9.1 into 10 power minus 31 kg. So, y component of acceleration comes out to be 1.6 into 10 power, this is 10 power minus 19 by minus 13 will give 10 power plus 12, it is 10 power 14. Now, y component of velocity equal to ay into time taken. Time taken is 10 power minus 7. So, it will be 1.6 into 10 power 7 meter per second or 16 into 10 power 6 meter per second. It is given with option 4. Let us go to the next question. In this question, a bob of mass m is suspended at point O by a light string of length L and left to perform vertical motion as shown in figure. Initially, by applying a horizontal velocity v naught at the point A. The string becomes slack when bob reaches at point D. The ratio of kinetic energy of bob at points B and C is. It is given that string becomes slack at D. It is becoming slack at D means particle should reach D with non-zero velocity. It is impossible to reach particle the point D with zero velocity. So, at the highest point D, minimum speed of particle will be square root of Lg. Now, if I consider minimum speed at the highest point is square root of Lg at point C, as it falls through height h1, where h1 equal to L minus L cos 60. This is L by 2. Similarly, for point B, it is falling through height h2. h2 will be in this case L plus L cos 60. It will be 3L by 2. Now, from energy conservation, speed at point C is asking ratio of kinetic energies. Now, kinetic energy at point C can be written as half m Vc square equal to half m Vd square plus 2g h1. Similarly, for point B, half m Vb square equal to half m Vd square plus, so this is mg h1. Similarly, in this case it is mg h2. Now, ratio of these two, this is kinetic energy at C, this is kinetic energy at B. Kc by Kb comes out to be half m Vd square is nothing but here Vd we are having the value. So this is equal to half m into Lg, Vd square equal to. So this is m into Lg by 2 plus mg, H1 is also L by 2 divided by, similarly here mg into L by 2 plus H2 is 3L by 2. So this is mg into 3L by 2. So taking mgl by 2 common, this is 1 plus 1 divided by, here it is 1 plus 3. So this is 2 by 4, ratio will be 1:2. So B by C will be 2. Let us go to the next question. A closed argon and an open argon tube are filled by two different gases having same bulk modulus but different densities rho 1 and rho 2 respectively. Frequency of ninth harmonic of closed tube is identical with fourth harmonic of open tube. Suppose if it is closed tube, let Lc is length of closed tube, rho 1 is density of gas in this case, and B is bulk modulus. Let L naught be the length of open tube, rho 2 is density of gas filled here, and B is bulk modulus. It is given that ninth harmonic means 9 times of fundamental frequency of closed pipe is identical with fourth harmonic of open pipe, 4 times of F naught of open pipe. Now fundamental frequency of closed pipe can be written as speed in closed pipe by 4 times of length of closed pipe. Similarly, fundamental frequency of open pipe is speed in open pipe by 2 times of length of open pipe. Now he is asking for length of open tube by giving length of closed tube. LC is given, we need to find L naught. So expression for L naught can be rewritten as 8 times of V naught by Vc into Lc by 9, 8 by 9 times of V naught by Vc into Lc by 9. Lc is given as 10, so this is 80 by 9 in centimeters. V naught by Vc can be written as square root of, as speed of sound in gaseous medium is square root of B by rho form, and bulk modulus is given same for both the gases. So it is inversely proportional to densities. V naught by Vc will be rho c by rho naught. So it is coming out to be 80 by 9 into square root of rho c by rho naught will be rho 1 by rho 2. The value of rho 1 by rho 2 given is 1 by 16. So it will be 80 by 9 into 1 by 4. Finally it will be 20 by 9. So option is 4 here. Let us go to the next question. An amount of ice of mass 10 power minus 3 kg and temperature minus 10 degrees centigrade is transferred to vapor of temperature 110 degrees centigrade by applying heat. The total amount of work required for this conversion is. So given that specific heat of ice, specific heat of water, specific heat of steam, latent heat of ice and latent heat of steam, everything is given, but there are many phases here. So let us note all those phases. Initially ice is at minus 10 degrees centigrade. Now we need to convert ice from minus 10 to 0 degree centigrade. Again 0 degree centigrade ice to be converted into water, water of 0 degree centigrade. 0 degree centigrade water should be converted into 100 degree centigrade water. Now 100 degree centigrade water should be converted into vapor at the same temperature 100 degree centigrade. Again this vapor should be raised to temperature of 110 degree centigrade. So these are all the many phases. So let Q1 be the amount of heat to be supplied here, Q2 is amount of heat, Q3 is amount of heat here, Q4 here and Q5 here. So total heat Q equal to sum of all these, where Q1 is from ice to ice, that is from minus 10 to 0 degree centigrade. So rise of temperature is 0 minus of minus 10 plus 10. So m into specific heat of ice into rise of temperature is 10 plus. Now ice to water 0 degree centigrade, m into latent heat of fusion plus water to water 0 to 100 degrees centigrade. So, this is m into specific heat of water into rise of temperature 100. Again water to vapor at 100. So, mass into latent heat of vaporization plus again vapor to vapor raised by 10 degrees centigrade, mass into specific heat of vapor into rise of temperature 10. In all these expression taking m common, specific heat of ice given is 2100 into 10 plus latent heat of fusion 3.35 into 10 power 5. Let me write this as 335 into 10 power 3 plus specific heat of water 4180 into 100 plus latent heat of vaporization 225 into 10 power 4 plus specific heat of vapor given is 1920 joule per kg Kelvin into rise of temperature 10. So, substituting the value of m as 10 power minus 3 and taking 10 power plus 3 common, it comes out to be 21 plus 335 plus 418 plus 2250 plus 19.2 here. Adding all this we will get 3043 joules. So, it is given with option 1. Let us go to the next question. An electron in the ground state of hydrogen atom has orbital radius of 5.3 into 10 power minus 11 meter, while that for the electron in the third excited state, third excited means here n equal to fourth state, ground state means n equal to 1, where n is principal quantum number. Ratio of de Broglie wavelengths of electron in the ground state to that in the excited state. So, we know that relation between de Broglie wavelength and total length of the path followed by the electron in a particular state as 2 pi r n equal to n lambda. So, in this case for ground state 2 pi r naught equal to 1 lambda naught. In case of fourth state the same thing, 2 pi R4 equal to 4 times of lambda 4. He is asking for ratio of ground state to excited state. So, let it be equation 1, this is equation 2. Lambda naught by 4 times of lambda 4 equal to, so it should be R naught by R4. This is R naught by 4 square times of R naught, this is 1 by 16. So, lambda naught by lambda 4 coming out to be 4 by 16, this is 1 by 4. Actually answer is not there, but best possible answer we can kept is second option, that is given as 4. Let us go to the next question. Which of the following circuits represents a forward biased diode? 4 diagrams are given here. In case of forward bias, P side should be at higher potential, N side should be at lower potential. So, in the first case P side is at lower, N side is at higher, so it is not in forward bias. In this case N side is at minus 15, P side is at minus 10, so it is in forward bias. And in the third case it is 4, it is 2, it is also forward bias. In case D it is given in the reverse, so it is at minus 10, it is at minus 5, it is also, it is at lower potential, it is at higher, so it is in reverse bias. In case E it is 2, it is 0, it is also in forward bias. So, B, C, E are the diagrams in which diode is in forward bias. So, option 2 is correct here. Let us go to the next question. A parallel plate capacitor of capacitance 40 microcoulomb is connected with 100 volt power supply. Now, intermediate space between the plates is filled with dielectric of constant K equal to 2. Due to the introduction of dielectric material, extra charge and change in electrostatic energy in the capacitor respectively. Suppose when there is no introduction of dielectric, let us assume capacitance of capacitor to be C naught, usually this is epsilon naught A by D. When dielectric material is introduced, capacitance of capacitor will be K times of epsilon naught A by D. Here battery terminals are connected, so initial charge Q naught equal to C naught V naught, new charge Q equal to CV naught. This is k times of C naught V naught, here k equal to 2. So, this is 2 times of C naught V naught. So, extra charge supplied by battery equal to Q minus Q naught. This is 2 C naught V naught minus C naught V naught. It will be C naught V naught numerically, where C naught is 40 microfarad, voltage is 100 volts. So, this is equal to 4 millicoulomb. Now, extra energy stored, initial energy stored U naught equal to half C naught V naught square. After introduction of dielectric material, energy stored will be half K C naught V naught square. So, extra energy delta U equal to U minus U naught. This is half K minus 1 C naught V naught square. It comes out to be numerically half C naught V naught square. So, this is C naught by 2 V naught into V naught. So, it will be 0.2 joules. So, it is given with option 1. Let us go to the next question. The diagram given below, there are 3 lenses formed considering negligible thickness of each of them as compared to mod R1 and mod R2, that is radii of curvature for upper and lower surfaces of glass lens. The power of the combination is. So, here 3 lenses are given. Let me separate those. This is of lens L1. Next lens is given like this, it is of lens L2. Next lens is given like this, it is of lens L3. It is of liquid lens of refractive index 4 by 3. It is glass lens of refractive index 3 by 2. It is again liquid lens of refractive index 4 by 3. Radius of curvature of this is infinity, radius of curvature of this is R1. Similarly, for this it is R1, for this it is R2, this is also R2, this is again infinity, this is also liquid lens. So, he is asking effective power of the system. Effective power P equal to P1 plus P2 plus P3, where P1, P2, P3 can be written as 1 by F1 plus 1 by F2 plus 1 by F3. General expression for 1 by F is mu minus 1 into 1 by R1 minus 1 by R2 form. Let us calculate for all the lenses. 1 by F1 equal to mu 1 minus 1 into, assuming all lenses are kept in air, 1 by R1 minus 1 by R2 form. Here R1 is infinity, R2 is R1 with negative sign here. So, it will be minus R1, it comes out to be 4 by 3 minus 1 into 1 by infinity minus of minus plus 1 by R1. Similarly, 1 by F2 equal to mu 2 minus 1 into, for this 1 by R1 is R1 as usual with negative sign. So, this is minus 1 by R1, this is also negative. So, minus of minus plus 1 by R2, the value of mu 2 is 3 by 2. So, 3 by 2 minus 1, this is 1 by 2 times of 1 by R2 minus 1 by R1. Similarly, 1 by F3 can be written as 4 by 3 minus 1 into, in this case R1 is minus R2. So, this is minus 1 by R2 minus R2 is infinity. So, from all these expressions, power equal to 1 by F1 is 4 by 3 minus 1, it is 1 by 3 into 1 by R1 plus, from this expression 1 by 2 into 1 by R2 minus 1 by R1. This gives 1 by 3 into minus 1 by R2. So, by simplifying this expression, finally it is coming out to be the first option, minus 1 by 6 into 1 by mod R1 minus 1 by mod R2. Let us go to the next question. 36th question. Given below are two statements, one is labeled as assertion and other is labeled as reason. If Young's double slit experiment is performed in an optically denser medium than air, then consecutive fringes come closer. Second statement, speed of light reduces in an optically denser medium than air while its frequency does not change. In the light of above statements, choose the most appropriate answer from the options given below. Here first statement is in YDSC, in optically denser medium, consecutive fringes comes closer. We know that fringe width in the normal YDSC is d by d into lambda. Similarly, if it is kept in a medium of refractive index mu, it will be d by d into lambda by mu. It is clear this is less than beta naught. This is because wavelength of light will be reduced in the medium having some refractive index mu. It is because speed of light is less than that in the air medium. So here first statement is correct, second statement is also correct, and second statement is correct explanation of the first statement. So answer comes out to be third option here. Both A and R are true and R is the correct explanation of A. Let us go to the next question. Given below are two statements. The equivalent EMF of two non-ideal batteries connected in parallel is smaller than either of the two EMFs is the first statement. Equivalent internal resistance of two non-ideal batteries connected in parallel is smaller than the internal resistance of either of the two batteries. When two batteries of EMFs E1 and E2 having internal resistances R1 and R2 are connected in parallel like this. Now if you write the effective EMF in this case, it comes out to be E1 by R1 plus E2 by R2 whole divided by 1 by R1 plus 1 by R2. For the combination of two cells, it can be rewritten as E1 R2 plus E2 R1 by R1 plus R2. Similarly, effective internal resistance will be 1 by R equal to 1 by R1 plus 1 by R2. We can prove it mathematically, R equal to R1 R2 by R1 plus R2, which is always smaller than smaller one. So it is always less than R1 and R2. So the second statement is correct here. Equivalent internal resistance of two non-ideal batteries connected in parallel is smaller than the internal resistance of either of the two. That is correct. But the first statement, effective EMF is not necessarily smaller than that. Suppose if I take E1 equal to E2, R1 equal to R2, then effective EMF also comes out to be E. So first statement is wrong here, second statement is correct. So it is given with statement second option. Statement 1 is false, statement 2 is true. Let us go to the next question. Which of the following resistivity versus temperature curves is most suitable to be used in wire bound standard resistors? Wire bound standard resistors means usually the material used for that is nichrome. In case of nichrome, resistivity varies very slowly with temperature. Almost it is independent of temperature. So here corresponding graph is shown with only first option. Here variation is very small. Let us go to the next question. A line charge of length A by 2 is kept at the center of edge BC of a cube A, B, C, D, E, F, G, H having edge length A as shown in the figure. If density of line charge is lambda coulomb per unit length, then total electric flux through all the faces of the cube will be, take epsilon naught as the free space permittivity. Here it is said charge of line charge of length A by 2 means total charge is A by 2 and charge per unit length given as lambda. This is the charge. It is enclosed inside the cube. Here there is some ambiguity with this question. Suppose if it is mentioned it is an imaginary cube, we can assume the situation like this. If it is imaginary cube, I can assume this charge to be kept in this way. In this case, it can be assumed to be enclosed with 4 identical cubes. I can enclose this charge with 4 identical cubes. In that case, flux linked with each cube will be 1/4 of the total flux due to symmetry. In that case, flux due to each cube comes out to be 1/4 times of total flux q by epsilon naught, that is 1/4 times of a lambda by 2 epsilon naught. It will be a lambda by 8 epsilon naught. But here it appears to be some physical cube is given and charge is completely kept inside the cube. In that case, total flux through all surfaces of cube comes out to be total charge enclosed by epsilon naught. So in this case it will be a lambda by 2 epsilon naught. So as question is not clear, so I hope they will give double key for this, either second option or third option. NTA given key as third option, but so it is better to go for double key for this question. Let us go to the next question. This is also assertion reason question. In Vernier calipers, one Vernier scale division is always smaller than one main scale division. The Vernier constant is given by one main scale division multiplies by number of Vernier scale divisions. Clearly the second statement is wrong. Usually Vernier constant is one main scale division minus the value of one Vernier scale division. So second statement is clearly false. So we can go for answers either 3 or 4 where false statement is given with second one. Now if you go to the first statement, in a Vernier calipers, one Vernier scale division is always smaller than one main scale division. Usually in laboratories we use that type of Vernier scales, but practically there is a possibility of having other type of Vernier scales also. In case of standard Vernier calipers, Vernier scale division is less than main scale division. In case of non-standard Vernier calipers, Vernier scale division value may be greater than main scale division also. Similar question was asked in JEE advance also. So it is better to give the answer as fourth option, statement 1. It should be given third option, statement 1 and statement 2 both are false in this case, but NTA given fourth option as correct. So I hope they may change the key, or better to give double key for this also, because there is some ambiguity in the question. At least they should not mention the word always. In general it should be mentioned. In Vernier calipers, one Vernier scale division in general is smaller than one main scale division will be the correct statement. Let us see what do they do finally. Let us go to the next question. Given is a thin convex lens of glass of refractive index mu and each side having radius of curvature r. One side is polished for complete reflection. At what distance from the lens and object be placed on the optic axis so that image gets formed on the object itself. So it is mentioned that thin convex glass lens of refractive index mu, each side having radius of curvature r. This is also r, it is also r. One side is polished for complete reflection. So let us assume it is silvered. If it is silvered, finally it behaves as a mirror of power Pm. Power of mirror in this case can be written as 2 times of power of lens plus power of mirror, because this combination can be taken as equivalent to combination of convex lens and concave mirror. So in this case this can be rewritten as minus 1 by focal length of mirror 2 times of 1 by focal length of lens minus 1 by focal length of mirror. Power of mirror is minus 1 by focal length of mirror. So this is 2 times of mu minus 1 into 1 by r1 minus 1 by r2 gives 2 by r here, minus fm gives minus r by 2 in this case. The value of mu is not mentioned. So this will be 4 times of mu minus 1 by r plus 2 by r. So on simplification 1 by fm will be 4 mu by r minus 2 mu by r we left with. So fm equal to, taking r LCM, it comes out to be r by 4 mu minus 2. If it is the value of focal length, object should be kept at a distance of 2 times of m. This is radius of curvature of the given system. then image will be formed at the object itself. So 2 times of Fm will be r by 2 mu minus 1. It is given with option 3. Third option is correct. Let us go to the next question. If B is magnetic field and mu naught is permeability of free space, then the dimensions of B by mu naught is, we know that dimensions of B by mu naught is nothing but H. It is also called magnetic field or magnetic intensity. It consists of dimensions ampere per meter. So ampere into length inverse. It is given with option 4. Let us go to the next question. Two spherical bodies of same materials having radii 0.2 meter and 0.8 meter are placed in same atmosphere. Temperature of smaller body is 800 Kelvin and temperature of bigger body is 400 Kelvin. If energy radiated from smaller body is E, then the energy radiated from bigger body. So in this case we need to apply Stephen's law. According to Stephen's law, power radiated will be sigma AE T power 4. As it is given both are identical bodies and surrounding temperature is assumed to be neglected. So simply this is amount of energy radiated by the body per unit time into area already multiplied here. So it is just total amount of energy radiated per unit. Now P1 by P2 comes out to be sigma and E both are common for both, A1 by A2 into T1 by T2 power 4. A1 by A2 can be written as R1 square by R2 square. Similarly, T1 by T2 whole square. Now it is given E is for the smaller body, E is asking for the bigger body. Suppose if it is E, we need to find the value of E prime. For smaller body 0.2, it is 0.8. So this is 1 by 4 whole square into T1 by T2 is 800 by 400, this is 2 power 4. 1 by 4 whole square is 1 by 16, 2 power 4 is also 16, ratio is coming out to be 1. So E prime equal to E. So this is given with second option. Let us go to the next question. The work functions of cesium and lithium metals are 1.9 electron volt and 2.5 electron volt respectively. If we incident a light of wavelength 550 nanometer on these two metal surfaces, then photoelectric effect is possible for the case of. Let us find the energy of incident photon. Energy of incident photon is Hc by lambda. This can be written as 12414 electron volt angstrom by 550. It is given in nanometers, in angstroms it is 5500. It comes out to be around 2.25 electron volt. So as it is less than 2.5, it is not possible to emit electrons from lithium, but it is possible to emit electrons from cesium. So only from cesium this light can emit the electrons. Let us go to the next question. A uniform circular disc of radius r, it is given disc, and mass m is rotating about an axis perpendicular to its plane and passing through its center. A small circular part of radius r by 2 is removed from original disc and shown in figure. Find moment of inertia of remaining part of original disc about the axis as given above. So first of all, moment of inertia of original sphere will be, sorry, in this case it is disc given, mass of disc is m, radius r. About its central axis, original moment of inertia is mr square by 2. Now moment of inertia of remaining part means, if it is I, this is I1 minus I2, where I2 is moment of inertia of removed part, I1 is mr square by 2, I2 again we need to use parallel axis theorem here. Moment of inertia of this removed disc from here to here, about its center of mass IC comes out to be, mass of removed part will be 1 by 4 times of original mass. So it is m by 4 r by 2 whole square by 2, it comes out to be mr square by 32. Now using parallel axis theorem from here to here, I2 will be m by 4 this distance is r by 2, mr square by 4 plus mr square by 32. So, taking 32 LCM, this is 3 times of mr square by 32 and original value mr square by 2. I1 minus 3 by 32 times of mr square. So, it will be 13 by 32 times of mr square given with option 2. Let us go to the next question. Two soap bubbles of radius 2 centimeter and 4 centimeter respectively are in contact with each other. Radius of curvature of the common surface in centimeter. Suppose two soap bubbles are in contact with each other like this. So, assuming this is of smaller radius 2 centimeter, it is of the larger radius 4 centimeter. Radius of curvature of common surface in this case, suppose if P1 is pressure here, P2 is pressure here, as pressure difference is inversely proportional to radius, P1 will be greater than P2. So, on concave side pressure will be more usually. So, new surface will be formed with concave surface like this, whose radius of curvature can be some RC, let us say. Now, pressure difference from P1 to P2 is maintained by the new surface having radius of curvature RC. Suppose if P is pressure difference across the new, delta P equal to delta P1 minus delta P2 we can write. So, delta P equal to 4T by RC, delta P1 is 4T by R1 minus this is 4T by R2. So, RC equal to R1 R2 by R2 minus R1 form you will get. So, new radius of curvature of interface will be 2 into 4 by 4 minus 2. It comes out to be 8 by 2. This is 4 centimeter. So, 4 centimeter will be the answer here. Next question. Particle is projected at an angle 30 degrees from horizontal at a speed of 60 meter per second. Height traversed by the particle in the first second is h0 and height traversed in the last second before it reaches the maximum height is h1, ratio of h0 by h1. Suppose if it is the projectile projected at an angle 30 degrees with horizontal with speed 60 meter per second. Now, let us consider its y component. This is 60 sin 30. This is equal to 30 meter per second. Displacement in the first second is h1. Usually we can use uyt minus half ayt square form here. This is 30 into 1 second minus half 10 into 1 second square. This is 25 meters. In the last 1 second means that is same as that in the first second while it is projected horizontally from the highest point. So, that can be written as h2 equal to simply half g 1 square. First second from the highest point is same as that of last 1 second while it is moving up. This is h2. So, this is simply 5 meters. Now, ratio of h1 by h2 is 25 by 5, it is 5. So, here h0 by h1 should be 5, it is given as h0, it is given as h1, h0 by h1. Next question. The position vectors of two 1 kg particles A and B are given by RA equal to alpha 1 t square I cap plus alpha 2 t j cap plus alpha 3 t k cap. Let us substitute these values. Alpha 1 is 1, alpha 2 is 3n. So, it is t square I cap plus 3nt j cap. Similarly, alpha 3 is 2. So, this is 2t k cap. Similarly, RB, let us find directly velocity for this. Velocity of A equal to d by dt of position vector of A. This is equal to 2t I cap plus 3n j cap plus 2 k cap. Similarly, position vector of B, beta 1 t square I cap beta 2 t j cap beta 3 t k cap. In the original question it is given t, it is t square. So, let us modify this. It is beta 1 t I cap plus beta 2 t square j cap plus beta 3 t k cap. Substituting beta 1, beta 2, beta 3 values, it is 2 t I cap minus t square j cap plus 4 p k cap. Corresponding velocity V b equal to d by dt of R b. This is equal to 2 I cap minus 2 t j cap plus 4 p k cap. Now he is asking where t is in time n and p are constants, at t equal to 1 second modulus of Va equal to modulus of Vb, means magnitudes of velocities are equal, and velocities Va and Vb of the particles are orthogonal to each other, means Va dot Vb will be 0. At t equal to 1 second, magnitude of angular momentum of particle A with respect to position of B. Suppose if I assume this is particle A moving with velocity Va, this is position of B, position of A as seen from B to be calculated, velocity vector Va. So, angular momentum of A as seen from position of B means mass of particle into RAB cross Va. Angular momentum in the given situation is position of A as seen from B cross velocity of particle A. So, this can be written as I cap, mass anyway given as 1 unit only. So, I cap, j cap, k cap, RAB, position of A minus position of B we need to calculate, RA minus RB at 1 second. Ra at 1 second is I cap plus 3n j cap plus 2 k cap minus Rb 2 minus j minus 2I plus j cap minus 4p k cap. This is coming out to be minus I cap plus 3n minus 1 j cap plus 2 plus 4p k cap. Let us find the values of n and p first. Let us solve it for n and p. It is given that Va dot Vb equal to 0 first at t equal to 1 second. So, equating their dot product to be 0. This is 2i minus 2t plus 4p, 2t plus 3n plus 2 k cap. Anyway, at 1 second it will be 4 2i into 2i cap. This is minus 2 plus 3n, it will be minus 6n. Next, this is 4p into 2 plus 8p. This is equal to 0, let it be equation 1. Here again we need to use the magnitudes of velocities also equal. It is given that Va equal to Vb, which is giving Va square equal to Vb square also I can use. So, it is giving 4 plus 16p square, this is from Vb square at t equal to 1 second. Similarly, Va square, this is 4 plus 9n square plus 4. So, 4 plus 4 terms are getting cancelled, we left with 16p square equal to 9n square. 16p square equal to 9n square, this is one equation. Let it be equation 2. 4 minus 6n plus 8p equal to 0. From this it is clear 4p can be plus or minus 3n. If 4p equal to plus or minus 3n, let us substitute first plus 3n. 8p will be plus or minus 6n. If I assume 8p as plus 6n, we won't get any solution. If I assume 8p as minus 6n, then we will get the solution for 4 minus 12n equal to 0 or n equal to 1 by 3. From this we will get p equal to minus 1 by 4. Substituting these values for 48th question I am writing here. Angular momentum at the given instant equal to mass is 1 kg, I cap, j cap, k cap. So, this is position of A from B x component, position of A from B y component, position of A from B z component. This is velocity A x component, velocity of A y component, velocity of A z component. So, if you find this cross product, it comes out to be square root of 90. So, answer comes out to be 90 here. Let us go to the next question. Three conductors of same length having thermal conductivity K1, K2, K3 are connected as shown in figure. Area of cross sections of first and second conductors are same. Let us say this as A, this as A, this is 2A. And for third conductor it is double of the first conductor. The temperatures are given in the figure. In steady state condition the value of theta is. So, here all values are given K1, K2, K3, everything is given. This situation can be taken as parallel combination of two resistors connected in series with a third resistor like this. It is 100 degrees centigrade, it is theta, it is 0 degree centigrade. This is R3, this is R1, it is R2. Suppose if current flowing through this as I1, this as I2, this as I3. So, thermal currents can be related as I3 equal to I1 plus I2. I3 can be written as temperature difference by resistance, theta minus 0 by R3. Similarly, I1 temperature difference 100 minus theta by R1 plus temperature difference 100 minus theta by R2. General expression for thermal resistance R is L by Ka form. So, here length is same for all three resistors, cross section areas are different. For R3 cross section area is twice as that of R1 and R2. So, this can be written as theta by L by K3 into 2A. This is 100 minus theta by L by K1 into A plus 100 minus theta by L by K2 into A. In all these expressions A by L can be taken common. So, substituting the value of K3, 2 times of K3 is 135 into theta equal to 100 minus theta can be taken common, then we left with K1 plus K2, K1 plus K2 will be 180. So, this is 270 theta equal to 18,000 minus 180 theta. So, after simplification it comes out to be 40 degrees. So, your answer will be 40. Let us go to the last question. The driver sitting inside a parked car is watching vehicles approaching from behind with the help of his side view mirror, which is a convex mirror with radius of curvature 2 meter. Another car approaches him from behind with a uniform speed of 90 km per hour. When car is at a distance of 24 meter from him, magnitude of acceleration of the image of car in the side view mirror is A. The value of 100 A is. So, let us assume this as convex mirror of radius of curvature given is 2 meter. So, its focal length will be 1 meter. Let us assume this is the position of object moving with velocity v naught. So, we can write the relation for object and image distances as 1 by v plus 1 by u equal to 1 by f, and differentiating this expression we will get velocity of image with respect to mirror equal to minus m square into velocity of object with respect to mirror. M is magnification. Expression for magnification of mirror is f by f minus u, but he is asking for acceleration. So, acceleration of image with respect to mirror is d by dt of velocity of image with respect to mirror. This is anyway velocity of object with respect to mirror is constant minus velocity of object with respect to mirror into d by dt of m square, m is variable here, minus velocity of object with respect to mirror into 2m into dm by dt. dm by dt can be written as minus f by f minus u whole square into minus du by dt. Minus du by dt is nothing but velocity of object. So, this is f v naught by f minus u whole square. This can be written as m square v naught by f. So, this can be minus of velocity of object with respect to mirror into 2 times of magnification into dm by dt is m square v naught by f. So, this is m square into v naught by f. Now, let us find the magnification in this case. M equal to f by f minus u. Focal length is 1, object distance is minus 24, this is 1 by 25 and velocity given is 90 kmph. Let us convert it into meter per second. 90 into 5 by 18, this is 25 meter per second. Now, if I substitute those values, this is 25 into 25, magnification cube we are getting, that will be 1 by 25 into 1 by 25 into 1 by 25. Again one more v naught term is there here. This is 2 actually, not v naught square. This is 2. So, one more v naught is 25, f is 1. So, simplification of this comes out to be 25, 25 gets cancelled, 25, 25 gets cancelled, we left with 2 by 25. He is asking for 100 times of this. 100 into 2 by 25 gives 8. So, answer will be 8 for this. Thank you.